This is the brief on the Trojan test. When you look at a system like Pluto and its moon Charon, you have to wonder, is that really a moon, or are they more like partners in a dance? It's a big cosmic question. How do you actually know if one thing is orbiting another, or if they're a true binary system? Well, that's where a really neat solution called the Trojan test comes in. So first, the old way of figuring this out, it just doesn't work. For decades, we used something called the barycenter criteria, basically seeing if the shared center of mass was inside the bigger object. But honestly, it's a physical failure. It's just an idea on paper. The entire solar system's center of mass actually pops in and out of the sun. And you know what? Nothing happens. Okay, so what's the better way? Second, we have the Trojan test, and it's all about these special spots in space called Lagrange points, specifically L4 and L5. Just think of these as super stable parking spots in orbit where gravity and momentum perfectly balance out. It's where smaller things, like the famous Trojan asteroids, can collect and just hang out. And finally, here's the absolute key. Those L4 and L5 spots are only stable if the bigger object is more than 25 times the mass of the smaller one. That's the magic number. Earth is about 80 times heavier than the moon, so the moon is definitely our satellite. But Pluto? It's only about 8 times heavier than Charon, so those Lagrange points become unstable, meaning it's a binary pair. This simple physical rule, whether Trojans can exist or not, is the definitive test for telling a binary system apart from a primary and its satellite.